quick version of what the data points unit does at Ginkgo?
Absolutely. Datapoints, I think, is the distillation of everything Ginkgo has built for the last 10 plus years. And so it's really taking our automated foundry, all the robotics that we have there, all of the data infrastructure that we have to pull data from those robotics, and providing that as a service to the industry so that the industry can build large multimodal data sets to train AI. This can be in discovery, such as building foundational models for understanding how a cell responds to different perturbations. It could be also for protein design, how to think about building the right antibody that has not only just binding affinity, but also the drug-like properties required to actually make it into a product. And so this is almost more CMC or early stage development, but doing this not for just a couple of lead compounds, but actually doing it for tens of thousands of compounds to allow you to build a training model that then can become much more predictive and allow you to make better decisions, not only for the campaign you're currently running, but for future campaigns.
So this is AI in the old sense, right? We're not talking about generative AI. This is large, big data sets, algorithms, models. How long have you been in this space? I mean, data points, but also you.
Yeah. So Datapoint's actually launched in September. And so this is a new offering. I would say that it is tackling the bottleneck for bio AI where it really exists, and that is it's not in the GPUs, it's not necessarily in the algorithms or the architectures, it's really in the data. And so what we have is, for biology, the one thing that everybody points to, also around the time that Datapoint's formed, maybe in October, is you had the Nobel laureate for AlphaFold, right? And so this was using the AlphaFold model that DeepMind had discovered, and along with Google, and allowing you to predict the protein structure based off the protein sequence. The way that that actually came to be was because we have decades of data to go off of, highly structured data that protein crystallographers, structural biologists have actually been contributing to Protein Data Bank for year over year over year, and all in the same format. And so fortunately, we were able to mine that and use that for training AI to now make AlphaFold. The challenge for all the other domains of biology, and there's so many other domains, is that you just don't have that data that exists that is all structured and also labeled. And those are the really key fundamental components. And so pharma especially has such a rich history of data generation, and they have data all throughout their various departments. And some of it's siloed, so some of it's actually like a bureaucratic issue, if you will. But oftentimes it actually comes to the structure of the data. The data just wasn't meant to be used for AI training, and there just isn't enough of it that is kind of consistent that you can put together in aggregate to sum up to that like meaningful training data for a model. And so sometimes the approach is just start from scratch. And with automation, the ability to do high throughput biology, you can actually ramp up your data generation intentionally in a very short period of time. And so that's really where it comes down to. It's actually data for the new age of AI biology, but it's really allowing us to generate new algorithms with the right type of data behind it. I've been in the AI space not too long. I think that we're all kind of adjusting to this new world. I have a deeper history in bioinformatics. I came from Pfizer before Ginkgo, where I was in business development, search and evaluation in RNA medicine space. And in RNA medicines, bioinformatics plays a really big role. There's billions, if not infinite number of different combinations that you can use to build an mRNA structure, right? And so this is kind of like the thesis here of AI and nucleic acids, is that you can use AI to actually pick the right sequence for mRNA. And we do some mRNA stuff in Ginkgo as well, including models that can actually spit out generative models that can predict the more stable structures for mRNA. So that's an example. And so before Pfizer, I was in bioinformatics at various biotech companies, running large screening campaigns, doing that therapeutic drug development. So I would say I've always been interested in large data sets, kind of that scaled approach to biology, understanding that if you take a couple of shots on goal, it just probably isn't enough to explore all the empirical space biology, but you really need to take large expansive campaigns in order to at least start to understand what could be the best combination when you're thinking about engineering the right parts and putting all these pieces together.
So then how do you take that idea of building sort of the AlphaFolds for all these other parts of biology that don't have clear data sets? How do you take that idea and make it into a business model? Who are your customers, and what kind of guides what you're working on and when and how you're prioritizing it?
Great questions. What we're really focused on is building up workflows that people already buy into. That is that we're not trying to prove that, hey, you should be doing this assay, or maybe this is a really good readout that you should consider. No, it's more about things that people are already doing, companies are already doing and spending money on, either internally or externally, but now scaling that up to a new level. Where it used to be, okay, we're used to these 12 assays that we use, these biophysical characterization for antibody developability. These are the gold standard, and if you run these assays and it all comes at the end, you know you have a molecule that shouldn't cause you any problems when you get to the clinic. Now, there's always surprises, right? But in general, it's all agreed that these 8 to 12 assays are meaningful, right? And so the question is, how do we scale that up? How do you do this in the orders of tens to hundreds of thousands so that you can actually build predictive models off of it? And that's really where we're gearing all of our infrastructure that we have, and now and mindset too, and operations, and putting that now towards building these data sets. And so we're not convincing people of doing something new per se, but we're convincing them to do it at scale now so that they can feed it into AI models